Good morning. Welcome to Civil with CRK. This session we will learn how to calculate the centroid coordinates for the given area here. Let's see the question. With respect to the given axis, locate the centroid of the area shown below. Okay. Yeah. So this is the given area. Yeah. Just trying to close this. Okay. Yeah, this is the axis mentioned by the question here. So let us say this is y-axis, and as this will be your x-axis. Okay. Yeah. So we need the centroid to be located for this area, which we see this for this area. Okay. Right. Now I'll try first get the area, given hatched area, by making the regular shapes, because this hatched area is irregular. Okay, now let's try to extract this hatched area from the regular shapes. Okay, yeah, just try draw a vertical line here. Okay, then try draw a vertical line here. Okay, and then yeah, so this I call this triangle here formed here as 1. Then the rectangular area which you see it here, I call this as 2. Then I call this triangle as 3. Okay, and this semicircle formed here, I call this as 4. Okay, now to get this hatched area, so I need to add the triangle plus the rectangle, this full rectangle, and then the another triangle here, and then I shall deduct this semicircle. Okay, so this is how I get this hatched area. Okay, for that we want the centroid. Okay, yeah, the formula goes like this. If you want x bar value, the location of centroid x coordinate is like a1 x1 plus a2 x2 plus a3 x3 minus a4 x4 divided by a1 plus a2 plus a3 minus a4. Yeah, so this is the formula. Okay, as you see, the area 4 is being deducted here. So the negative sign you shall not forget. Okay. Yeah, now let us try formulate all these properties. What is A1, X1, what is A2, X2, and what is A3, X3, and A4, X4. Okay. Yeah, consider the first area. See here. Yeah, this total is 18, where this I have dropped down. So this is 12. This is 12. Okay. So remaining is 6, and it is equally divided here 3 centimeters and 3 centimeters. Okay. So now this triangle for me is 3 centimeters base, 6 centimeters height. Okay. So let us draw that one. So now I am writing element 1 properties. Okay, right. So element 1. Now the element 1 is a triangle. Try draw that triangle. Okay, yeah, the way it is actually. So 3 centimeters and 6 centimeters. Okay. Yeah, your axis, you locate the axis. Yeah, the x-axis is passing through the base and y-axis is at a distance. Yeah, so this total is 12, right? And this is at midpoint, so 6 centimeters. Okay, so from here it is at the y-axis is at 6 centimeters. So y-axis, this is x-axis. Yeah, this is 6 centimeters, whereas this is 3 centimeters. Okay, yeah, this is element 1 now. Okay, yeah, for this, now if you observe the figure, okay, so this here, this is symmetric, this entire area is symmetric about y-axis, which means centroid lies on y-axis. Okay, so where the centroid lies on y-axis, its x-coordinate is 0. Okay, so which means this x bar is 0. Okay, so which means you need to only locate y bar distance. Okay, so the centroid coordinates x bar comma y bar are now 0 comma y bar value. Okay, so if you just work out for y bar, it is sufficient. Okay, which means along this line where the centroid is located. Okay, that is the y bar value. Right, so here for writing properties of element 1, I need a1 value, I need y1 value, because y bar formula consists of a1 y1 plus a2 y2 plus a3 y3 minus a4 y4 divided by a1 plus a2 plus a3 minus a4. Okay. Yeah, a1 I'm writing half base into height. Okay. This works out to 9 centimeters. Okay. Yeah, y1 value. Locate the centroid from x-axis at what height it is. So divide this 6 centimeters into 3 equal parts. Okay. So each one is 2 centimeters and 2 centimeters and 2 centimeters here. Okay. So this is the centroid of the triangle location. Okay. So this is h by 3 from base. H by 3 from base. Okay. So which means 6 by 3. So 2 centimeters. So this is y1. Okay. Similarly, you write the other properties also. Like let us see element 2 is a rectangle. Just try draw the rectangle. Okay. Yeah. So rectangle is actually 12 centimeters length and 6 centimeters the breadth or depth, what you call. Okay. Yeah. The x-axis is at the base, the bottommost horizontal line, and y-axis is passing through the centroid of the rectangle. Okay. So this is y-axis, right? Yeah. So now the properties A2 area of this rectangle 12 into 6 72 centimeters square. Y2, so the centroid of the rectangle is very well known to us. It is exactly at the midpoint. So this is its y distance. Okay. So this is y2. The total height is 6 centimeters. So it is again 6 by 2, 3 centimeters. Okay. Yeah, now the element 3 is a triangle again. Okay. So try draw the triangle. Okay. 3 centimeters and 6 centimeters. Yeah, same. The now y-axis is located to the left of the triangle. To the left of the triangle. This is y-axis, and this is x-axis. Okay. Again, the centroid is located the same way. Like divide this into three equal parts. Yeah, the centroid lies at h by 3. So this is h by 3 distance. So now a3, okay, is like half base into height, half base height. So this comes again 9 centimeters square, and y3 is 6 by 3, 2 centimeters. Okay. Then the fourth one, element 4. So element 4 is a semicircle. Okay. So try draw the semicircle here. So as it is like this. Okay. Yeah, x-axis is exactly on the diameter line, and y-axis is like this. It's again symmetrical. Axis is now axis of symmetry. Okay. Yeah. So this is now the dimensions. If you see, this radius is given as 5. Okay. So this is 5 centimeters. Okay. Yeah, the centroid, okay, from the diameter line. So that is the location of centroid. Okay. Yeah, this we have derived. Okay. And the value is 4r by 3 pi. Okay. So now the properties are like A4, area of this semicircle, pi r square by 2. Okay. Yeah, which works out to be 39.27 centimeters square. Yeah, then y4 is 4 r is 5, 3 pi. So which works out to be 2.122 centimeters. So this is how we write the properties required for substituting into the formula. Yeah, now let's try substitute all these into the formula. Okay. Yeah, y bar is equal to a1 y1, a2 y2 plus a3 y3, a4 y4 divided by a1 plus a2 plus a3 minus a4. Okay. Right. So substituting all the values, like a1 is 9, y1 is 2, plus a2 is 72, y2 is 3, a3 is again 9, y3 is 2, minus 39.27 is a4, 2.122 is y4, divided by 9 plus 72 plus 9 minus 39.27, a1, a2, a3, a4. Okay, yeah, so this works out to 3.325 centimeters is y bar value. So the coordinates of centroid is 0, comma 3.325 centimeters. Okay. Yeah, if you just try to look at it, yeah, this here, yeah, centroid is lying on this line. So because the origin is kept here, the origin location. So this is the origin. Okay. Yeah. So from here, this is 5. This is, let us say, 2.5 midpoint, and 3.35, 325 somewhere here. So the centroid is at this location. This is X bar of this hatched area, and this is Y is nothing but Y bar of this area. So this is the centroid location. Okay, so 3 point, this height is 3.325 centimeters. Okay, yeah, this is how you need to practice locating the centroid for the composite areas. Thank you. See you in the next session.